Welcome and thank you for joining us for another episode of the JAIN Irrigation Training Series. I'm your host, Richard Rastuccia, and today we're going to be talking about backflow prevention. And, this is an interesting subject, right? Because it's really critical to the success of your landscape and really successful to water delivery in urban areas and agricultural areas. It's a subject that I think we all need some additional education on. I think it's a subject that a lot of times gets grouped into the plumbing business instead of the landscape, but for landscape, it's really important. And for ag applications, it's important as well. So I'm really happy today that Danny Martinez, the technical sales and training manager for ET Water, is joining us to help us understand more about backflow prevention, understand the basics, help us with helping select the right backflow device for our properties, and teach us in general the importance of backflow prevention and why. And that seems to be important, as well as is this an opportunity for landscapers to do some extra business in landscape in backflow prevention, testing, and installation. So we got a lot on our plate, but if you've heard Danny on here before, he does a great job in his training. Danny's been in this industry for over 18 years now, living, working in the field, working on landscape irrigation every day. He does just a tremendous job. We're really fortunate to have him. And Danny, welcome back. Really appreciate you coming on today.
Thank you, Richard. Thanks for having me.
Yeah, so Danny, I just want to ask you that first question. Do you see a lot of landscapers doing backflow prevention and backflow testing, or are they letting somebody else, some other industry, take care of that?
Actually, it's a cross-connection control program is actually kind of dominated by the plumbing industry. There is a lot of technical knowledge that needs to be put in place, and knowing of what kind of device we use, what you're protecting our water supply from. But there's definitely landscapers out there that do get involved with backflow, and it's something that they probably all should get a little more knowledge on.
Yeah, so why do you think the landscapers, a good majority of the landscapers, kind of shy away from it?
It could be just the regulations. There is quite a few rules that go into place. Some contractors, that's one less thing that I don't have to worry about it, and they don't mind subbing that work out. But actually, if you get into it, do a little research, you'll find that, hey, it's actually could be a great revenue stream for landscapers as well.
Yeah, so I think the education's rigorous, though. Don't you have to take a whole lot of classes and then relicense yourself every once in a while?
Yeah, absolutely. As a backflow tester, you do have to pass at least it's a 40-hour course minimum, with hands-on and written tests on all the devices for backflow.
Yeah. So, okay, well, interesting. We'll be interested to see how much of an opportunity this is for our listeners. So let's get started.
Absolutely. So let's get into what a backflow is. So backflow's been the common name that's been thrown out to discuss what it is. It's actually a cross-connection control device, but backflow for general purposes. And it's basically a simple valve. There's some technology in there having to do with hydraulics, but it's just a device that keeps water from going back the opposite direction. So we're trying to prevent that reversible flow.
So that's interesting, Danny, because I think, for my landscape, I don't know, I've got 60, 70 pounds of pressure. I'm always regulating it down. It seems pretty impossible for water to go back the other way.
Yeah, it is pretty rare that it happens, but it can, especially if you have something on your site, like we call it auxiliary water supply. Sometimes people have wells with pumps that boost pressure, and it could cause a cross connection where maybe it's plumbed incorrectly and it pushes water supply back to the domestic water supply, or in very rare instances, the city supply pressure could drop negative.
I see. And so then the danger here is that what water's been sitting in, or especially with the recent rains, where we had water puddling in our yards, that this could actually flow back into the system and into the municipal water.
Absolutely. For example, for landscape, Puddling water could pose a threat. We use chemicals, fertilizers, herbicides. We run lawnmowers. It could leak oil and gasoline onto the soil, and if that collects somewhere and we have a backflow incident, it could very easily go back into our domestic water supply.
Yeah. So I'm looking at this cruise ship and thinking I need some cruise ship time, maybe a little vacation. But what's the cruise ship got to do with backflow prevention?
So very interesting. Actually, the whole cross connection program kind of derived from the cruise industries several years ago. Cruise ships being concerned and worried about safety, obviously. But these boats are out there sloshing back and forth, and it poses a threat where, hey, their freshwater tanks could cross-contaminate with their gray and black water. So this cruise ships, we can thank for the creation of cross connection control, which protects our potable source of water. And USC, so USC, University of Southern California, is actually who these cruise lines went to and said, hey, we got a problem we need to fix here. So USC is the governing body of cross connection control.
Okay, go Trojans.
Yes, sir. So there's many reasons why we need backflow devices. Main purpose is to prevent anything from going back into our water supply. We kind of take it for granted here in the United States, especially, you know, for the most part, you can go up to just about any hose bib or water supply that's connected to a public source of water and drink safely from it. My dog loves it. That's why the little pup's there looking water. I don't know about yours. I grew up drinking from the hose myself. So it's for the most part, you're going to be safe. You know, maybe you need to flush the hose bib out a little before you take a sip. But our water quality here in the United States is very, very high standards. We can also thank the Safe Drinking Water Act of 1974, which set those standards. And as a result, sometimes you and I or property owners may be required to put a device in place to prevent a cross connection.
You make a very good point there, Danny. We do take two things for granted, I think. And one is that every time we turn the faucet on, water comes out, right? And I think we just learned, right? There was a community I saw in Arizona near where you are today. A couple of weeks ago, they stopped getting water, right, due to the drought. But we do very much believe every time we turn the faucet on or our irrigation on, water is going to come out, and we always expect it to be clean. So yeah, this is one thing we want to keep both those things going, right?
Absolutely. I mean, we like to preach water conservation quite a bit here at JAIN, and protecting that water is, I feel, a very big, important part of that also as well. This Safe Drinking Water Act 1972 is very important. You know, it's kind of set the standards for us as far as water agencies and how they can implement programs and maintain them. They also have to follow strict guidelines. When it comes to backflows, there's specific installation instructions. They have to be inspected. As you can see from the image below on the left there, you got a water meter to the left, and then the backflow device a little higher up. So there's standards, how high these need to be, clearances around it for testing, and nothing can be connected between the meter and the backflow. Also, now in most cases, as you can see here, it's all solid brass, could be hard copper, but we no longer allow like PVC or galvanized pipes to be used in this installation.
So this is where I start to have some trouble, right? Because one, this looks a little complicated. And I also know there's irrigation valves that are called anti-siphon valves. And do I need a backflow preventer if I have an anti-siphon? And just basically, how do I even figure out what type of backflow prevention device I need?
So one, that's going to be locally regulated. Your local water purveyor, each one has some flexibility and different standards in place. For instance, in a landscape situation, California, actually, and I believe Florida, are some of the only states that actually allow anti-siphon valves as adequate protection from backflow in the landscape. There's require like the image there that's considered a RP device, a reduced pressure principle device. But yeah, you want to consult with your local water agency or water purveyor. They can come out, do an assessment, and tell you what device you need to put in place. And also, you're kind of forced to comply because they have power to revoke water privileges if you don't follow necessary steps to protect the water supply.
Yeah. Well, it is a very serious subject, right? Because if you have a problem, you're going to make a lot of people sick, and we don't want that to happen. And I do want to remind everybody, Danny, that I do have the chat and the Q&A open. So if you guys have some questions or comments you want to add, please put them in there, and I'll relay them to Danny when it's appropriate. And I think we've been given some pretty good JAIN gear for people who ask good questions.
Yeah, thank you, Richard. Please ask away there. So, Richard, when it comes to backflow selection, like I said, your local water purveyor will be your best source to decide what kind of device to put in place, because we do have a couple situations. But as far as selection comes, we have two kind of different levels of deciding. So one is kind of the degree of hazard, and the other one is the cross connection type, which I'll cover here in a minute. But the degree of hazards basically breaks down to one of two atoms: is it a contaminant or is it pollutant? So considering a contaminant, that's anything that could pose a health hazard, So a facility that maybe deals with chemicals or detergents, something that if it were to go back into the water supply and somebody were to consume it, it's probably going to give quite a bit of health issues to somebody. Or the other one, like a pollutant, maybe somebody who's the manufacturer is doing like chocolate syrup. If chocolate syrup goes back into the water supply and be considered a pollutant, it's going to make the water look a little weird, maybe discolored, a little cloudy. But if you consume it, it's not going to harm you.
Okay, so pretty important to keep those two separate, right? And it's the not harm you is the important part that I like.
Correct. Yes. So different levels of hazard there, as we call it. And then here's a couple of hazards. Just for example, we touched on landscape. Stagnant water sitting there, valve boxes full of water. Sometimes these are sitting there. As a former landscape repair technician and also a former backflow tester myself, we come across this all the time. You open up a valve box or see a puddle of water, you probably maybe even have a fountain that you've seen sitting with larvae, mosquitoes, and all the other chemicals that may collect there. Very simple for that water to be pulled back into the water supply. We touched on an auxiliary water supply. So maybe you have a well on your site. If that pump were to be connected to the city supply and is pushing more pressure than the city supply line is, could very easily push anything from that well into our city water supply. Again, hazardous chemicals, different manufacturing levels. Not only would a business like this be required to have a backflow device at the meter, they may have multiple in between all these storage tanks and mixing tanks and of these chemicals. So you could be looking at several backflows for a business. One of the fun fact for we all love Starbucks, right? We know somebody who does, can't go with their Starbucks. So each Starbucks, actually, they have all their steam machines, mixing machines. Starbucks have over 25 backflows in each restaurant.
Oh my gosh.
Keeping things safe. Yeah.
Yeah. So there are times when you need more than one. And in their case, because of all the devices, they need 25 average.
Absolutely. I mean, even within your home, some people have a pond just like that. They throw a hose in there, let it fill up. Could be a koi pond, could be just a waterfall type of feature. A lot of sediment settles in there. Water sits for a while. The city main were to go into negative pressure, that water can be sucked back through that hose, through your house, and back into the water supply.
Yeah. When you start thinking about this, right, at first, you think, oh, how bad could it be? But it's really everywhere, right? For me, I use compost teas to fertilize my garden with a fertilizer injector. I wouldn't want that getting back, that's for sure.
Absolutely right. If you're using your spray there, what do we do? Put gloves on, you got a respirator, maybe some safety glasses, so you can protect yourself there. So this is kind of the same type of protection device for a water supply.
Yeah, and then you mentioned car washes here because I'm thinking, the car washes recycle all their water now, and you don't want that pulled back either, and it could be.
You don't, but I throw this one in here, and I encourage everybody to go online and just look up uh, backflow incidents, and you'll see some horror stories. This one, for example, car wash. There was a car wash up in Washington. These car washes do recycle their water, right? But all this water that gets rinsed off goes down into some sump tanks, and these tanks have pumps that pump that water back out to the sewers. So incident up in Washington there, that pump failed. So they had a contractor come out, they replaced the pump, actually installed the pump backwards and plumbed it into the domestic water supply. So that's soapy, detergent, all that bug wash, any road grime that was collecting down there got pushed into the local water supply. And residents were complaining that their water out of the fountains coming down a little greenish, felt a little slimy from the detergents. In which case, the city came, isolated it. They started doing investigations, and they traced it back to this car wash.
Wow, that's a real nightmare story. That's right. You're right about that.
Absolutely. And then we've all been to medical offices, right? I think I'm overdue myself for a dentist appointment. But what do? They put things in your mouth, right? They got the water jet, the suction going on in there. So dental offices, you can rest assured, they all have to follow strict guidelines. There's safety measures in there for health purposes. Obviously, behind every one of these dentist chairs is a backflow device, keeping anything in your mouth from going into the next seat's mouth and vice versa.
Yeah.
So backflow there that you don't consider, we kind of, nobody ever thinks about it, but this is why we put all these safety measures, things like this that we just don't even think about.
Yeah, it's really good awareness, right? And I hadn't ever thought about that until I saw your slides. That yeah, I don't want the next office over dentist chair that any of that coming into my water. That's for sure.
Absolutely, absolutely. So going back to our device selection, we got two different types of backflow. So one is back pressure. So Richard, you asked how can water go backwards, right? You see, it's pushing out 70 psi to your house. Well, you could have in these cases a pump that's pushing more pressure, right? So the pressure downstream of the meter is higher than what's coming in. Water could very easily go backwards. And the other one would be the back siphonage. So pretty rare instance that this happens for a city main to possibly lose pressure, but it can happen. One of the biggest things is, as you can see on our picture on the right, is a fire truck. Okay, so on the left, a booster pump pushing pressure that creates back pressure on your system. And if you look at the right side, a fire truck, Richard, a fire truck is really nothing much more. I mean, transporting the firefighters around. But if you look at the back end there, that's just a giant water pump back there that they used to pull water from the city main. So when they hook these fire trucks up to put out a fire, these fire pumps are designed a little different than what you see on the left. When we design a pump system for irrigation system, for example, we're going to try to push as much water through a piping system safely without breaking anything. Well, these fire trucks, their spec is actually called pump to destruction. They want to pull as much water as they can, put out fires as fast as they can. They don't care what happens to our infrastructure of our piping system for the city mains, because no matter what they do to it, you can't put a price on the life, right? So they want to put as much water as they can. They break pipes out there, so be it. We're going to save our lives. So this is a case where the city pressure could go negative.
Yeah, so that's really important to remember, right? Because when we just think about day to day and every day, that's not really what we're preventing against. It's for these special circumstances we have to have the checks and balances. So how do these backflow devices actually stop the water from going backwards?
So they have there's different types out there. So it kind of depends on those four parameters: the contaminant or pollutant, back pressure, back siphonage, your degree hazard there. But they basically have valves in place that prevent either liquid from returning back to the water supply. could be like the top left there, AVB, what's called an atmospheric vacuum breaker. This has a little float device that if pressure were to drop, that thing drops down, allows air to siphon into the water line instead of any water downstream. In the top center there, we got one's called a double check valve. It's basically a one-way valve, opens up in the direction of flow. If flow drops down below a certain PSI, they close off and doesn't allow any water to go back. And then the RP, top right, this is our biggest and best device out there as far as actual valve. So this one will protect against back siphonage, back pressure, contaminants, and pollutants, all the above. The only thing that this is not allowed to be used on is raw sewage and nuclear hazard types of material. Okay, in that case, you would need the bottom one there, which I'll touch on in a second. But Richard, you might have seen that bottom left one, the VB on one of your garden valves before.
Yeah.
So this is pretty similar to the top, the one right above it, the AVB. It allows air into the line, release back pressure into the system. And actually, by code, you should have one of these on every one of your garden valves on your property. So most new homes, or all new homes, should have them on their hose bibs. If you took it off, I recommend putting a new one back on, because usually what happens is you turn the water off, the hose contracts a little, pushes a little water, squirts a little water out of there, and might get you wet while you're closing it off. But that's doing its job there. Okay.
Interesting, right? Because I do see a lot of those around.
Absolutely. Yeah. They should be there. And then the center one, there's two that look very similar like that. You got a spill resistant vacuum breaker and a pressure vacuum breaker. This one kind of similar to that atmospheric vacuum breaker. It has a valve, opens up, lets air into the system. But it only has one single check valve, where the double check and the RP have two check valves to prevent water from going back. So this one can prevent against pollutants, but not necessarily all contaminants. And then the last one is one that we all use every day, right? The air gap. So that's Mother Nature's backflow device, literally a physical barrier between source of water, here, your faucet, and the vessel, so the sink, right? So there's actually regulations in the air. Next time you look at your sink, you might notice, hey, why is it the faucet above the tank level, right? And the reason is, if there were to be negative pressure line, air is going to get pulled into that pipe instead of the water from the sink.
Yeah. Okay. So the same thing too with our dishwashers when they're next to our sinks, right?
Absolutely. They have an air vent in there next to your sink that lets air in if there was a situation. And also there's regulations on how big that air gap has to be. So 2 times pipe diameter, no less than 1 inch, if you're interested in the numbers there.
Yeah. So again, Danny, this just here, we're looking at 6 different choices. If I contact my local water municipality, they'll come out and look at the application, or maybe they can tell me over the phone or through email which backflow device I actually need.
Yeah, absolutely. They would actually come out to your property, inspect the site, look at what kind of hazard you have, and determine what device will suffice. Most water agencies have just gone to the RP, the reduced principal pressure device, because it does offer the best protection. Yeah.
Are these expensive?
They could be, so you can see they're made out of brass in most cases. A lot of municipalities now required to be lead free. You're looking at brass, lead-free brass and copper going into the assembly of it itself. As you can see from the construction picture earlier, it can get a little pricey, especially when you consider you got ones that go down from 1/8 inch and 1/4 inch up to 24, 36 inch, big city mains that you've all driven by. I'll show you a picture here shortly, and on the drive home, you guys can say, hey, there's a backflow.
Yeah.
Yeah. They're all over the place.
And like you say, it is the material, right? This brass material is not inexpensive, and it needs to be sturdy for a reason.
Absolutely. So it has to be sturdy, Richard. On top of that, the guidelines of regulations to get a backflow approved for use on a city supply line is pretty rigorous. Like I mentioned, USC is the governing body. So anytime a manufacturer wants to get a device approved for use, it has to go through USC. They have to supply multiple devices from each size. So if they have from 1/4 inch, 3/4, 1 inch, all the way up to 24 inch, they got to send multiple ones to USC. They put them out in their parks and cities for a couple years and test them regularly. And they cannot fail once throughout that test. Otherwise, that whole batch is thrown out and they got to start all over again. And it's in the millions for testing these devices.
Yeah.
To get
Yeah,
approval.
good point. They have to be 100% accurate.
Absolutely, they cannot fail, and they do fail. But that's why we have backflow testers that are out there. So that's another part of the ongoing cost. These, by law, every backflow has to be tested annually. Also, anytime you do a repair or replace a backflow, it's supposed to be tested. So for all my contractor friends out there that are listening, anytime you do repair, please call a certified tester and get those tested.
And any of their certified testers, that's all the business they do, right? That's what they're in business for.
Absolutely, yeah. I did it myself for 3 years, just strictly tested. That was it. Go out, do a test, submit it. Most cases they do pass quite regularly. They're very good built products. But yeah, and there's cases where they will fail. Maybe debris goes in there. Very rare seal goes bad. Springs could crack and stuff, or just wearing out from opening, closing so much.
Yeah. So we do have a question coming in from one of the viewers, and I think you cautioned us on all the backflow preventers that none of them worked with raw sewage. Is there something separate or different when you working with raw sewage?
Yeah, so by code, no domestic water supply can actually be connected or plumbed onto raw sewage. So if there's water source that needs to be mixed with some sewage, you'd have to use the air gap.
I see. Okay. Okay. That makes sense. Yeah. That's a good rule.
Yeah. So here's for example, another thing, a lot of times you'll go to a backflow like the one on the left, there's dumping water, or even the one on the right, looks like a nice new install. Nothing wrong with it. Just because it's not leaking anymore and you've done a repair doesn't mean it's working properly. So you need to get that tested either way.
Yeah, so we mostly think of like an irrigation valve. It's faulty when it leaks, or when water's coming out when it shouldn't be, or no water's coming out. But these might look very normal, but there might be a problem anyway.
Correct. Something gets stuck in there. There's actually different pressures. If you notice on the picture on the left, the RP all has 4 test cocks. Some have 2, some have just 1, and a vent screw. There's specific test procedures and steps that have to be done for each individual check valve, relief valve in there.
Yeah, so we've got another question coming in, Danny. It's kind of a winterization question, and that is, do you need to test the backflow after you do a blowout of your system, for winter?
Good question. For blowout, yes, you're shutting that off and be highly recommended. But I would check with your local water agency to see if they require those backflows to be tested from a winterizing process.
Yeah, very good point.
So here's a couple that you might have seen on your property or around. Like you mentioned, Richard, your irrigation valve, your anti-siphon valves. You have on the top left there. Did you know, Richard, that anti-siphon portion, that big round cap, is supposed to be 12 inches above your highest sprinkler on the line?
Probably not there on this one.
There you go. So I guess I have that little bug. I go around and say that's not installed properly.
Yeah, so I would say then the high majority of what I see look just like this, not 12 inches.
Correct. Yeah, you need at least 12 inches. Reason for that is you gotta have enough room, flooding, hopefully not more than 12 inches, but we need to have 12 inches above the highest sprinkler to allow in the system. That hose bib on the top right, that's what yours should look like with that hose bib backing breaker on there. You landscape, we have them all over the place, usually near the meter, well, always near the meter, probably near that cage, just looks just like that. So when you're on property, you'll see that cage, hey, there's a backflow. And then you got city mains, big 12-inch, 24-inch that you'll see along the road, big, usually painted big blue and red handles there. That's a backflow.
Yeah. Okay. All right. That's cool. So that's the double check valve there on the big blue one there.
Correct. So double check, or it could be an RP if it has a relief valve on the bottom. So double check and RP could look very similar.
Yeah. So do all these backflow prevention devices, do they have to be installed above ground, or can you put them in ground sometimes?
So all need to be above ground with the exception of the double check, and that's per municipality, maybe a little bit different also. But the double check is the only one that can actually be put below ground.
Okay. All right. Interesting. Yeah. Thank you.
So, Richard, if you got anybody else has any questions, further information they'd like on backflows or anything JAIN USA or related, my email's here, dmartinez@jainsusa.com. Love to help them out.
Yeah, Danny, that was really a good presentation. I learned a lot, as always, when I do these with you, and very generous of you to offer your email address for questions. And let me tell you, if you have them, please feel free to do it. Danny's sincere in his offer, and he has a wealth of knowledge to help you out. Anyway, Danny, thanks very much. I want to thank everybody who joined us today. We're these days are long these days, and you spending some time with us learning about irrigation is important to us. So we hope we're meeting that challenge of what you want out of your training. And if you have some ideas, feel free to reach out to me and let me know if there's trainings you want to see. We'd love to provide that for you. And also remember, you can watch all our trainings at the jainsusa.com website /trainings. There's well over 200 trainings there for you to enjoy, or you can listen to them wherever you listen to your favorite podcasts. We pull the audio out and put it on a podcast. And I love to think that people are out there working in irrigation and educating at the same time. It's really cool. Again, Danny, thanks so much for joining us today. We really appreciate all this information, and we look forward to having everybody back next week.
Thanks for having me, Richard.
Yeah, you bet. Okay, thank you, everybody.